The Tesla Model 2, planned for release in 2026, has captured attention not because of its autonomous driving ambitions or potential robotaxi functions, but because it aims to offer a genuinely affordable electric car priced around $10,000. The real secret behind this possibility lies deep within Tesla's production strategy, long before any assembly robot moves or any metal panel touches a press. The Model 2 begins life as a highly optimized digital design shaped by principles that simplify manufacturing and assembly, allowing Tesla to cut costs at the earliest stage. Engineers work aggressively to reduce part count, merge separate pieces into unified structures, and eliminate anything that complicates production. Since the majority of a product's cost is established during the design phase, Tesla focuses on refining every joint, fastener, and surface, so the car can be built faster, with fewer steps, and with greater consistency. The shift from dozens of welded stamp panels to large single-piece castings dramatically reduces weld operations, tooling expense, and inspection time, while improving long-term durability by removing many failure points. Standardizing screws and fasteners also cuts down procurement cost and simplifies future repairs, as fewer component types need to be stocked. Many parts are crafted to align themselves automatically, so workers and robots can position them quickly without constant adjustment. Even small time savings accumulate across hundreds of thousands of cars, turning into significant cost reductions. Once the design is set, Tesla applies modular engineering to push efficiency further. Instead of constructing the vehicle from thousands of small parts directly on the frame, the Model 2 is assembled from major modules that reach the main line almost fully completed. The drive unit, battery pack, interior assembly, and front and rear structural blocks are all built independently with matching alignment points, bolt patterns, and connectors, allowing them to join with the body in a few simple motions. This approach not only reduces assembly time, but also lowers the chance of mistakes. Because modules can be produced in massive quantities, Tesla benefits from economies of scale, allowing shared components across different Model 2 variants or even entirely different Tesla vehicles. Lower-priced versions of the Model 2 can be created simply by combining different module options without major changes to factory equipment. Inside the production facility, Tesla further improves efficiency by optimizing material movement. Unlike traditional factories where parts often travel through chaotic routing, the Model 2 assembly system follows a mostly straight, one-way flow that reduces waiting time and eliminates unnecessary transportation steps. Kitting ensures that each vehicle receives a dedicated set of parts delivered directly to its station, eliminating wasted time searching for components. Selective automation means robots handle heavy, repetitive, or high-precision work, while humans take on tasks requiring flexibility or sensitivity to surface finish, preventing overspending on robots that offer little benefit. Quality assurance is built into every stage of production instead of waiting until the end. Throughout the line, sensors, cameras, and automated fixtures verify torque levels, panel alignment, electrical connections, sealing, and structural fit. When a deviation appears, the vehicle is corrected immediately rather than carrying the defect forward. Statistical process control helps engineers detect patterns that reveal early signs of tool wear or process drift, allowing them to adjust before flaws multiply. Strong process capability leads to fewer reworks, less scrap, and reduced warranty expenses. The final component of affordability comes from maximizing factory utilization. Tesla works to keep equipment running for long stretches through multiple shifts supported by predictive maintenance. The more cars a factory produces, the more its fixed cost is spread across each unit, sharply lowering cost per vehicle. When combined with streamlined design, modular construction, optimized workflow, smart automation, and inline quality checks, the Model 2 becomes not a miracle, but the inevitable result of a deeply refined manufacturing system. Everything works together to make a low-cost, reliable, and practical EV possible at a scale that could reshape the market. Building on the efficiency, modularity, and design principles established in Part 1, the Tesla Model 2 further demonstrates how every aspect of production is tuned to minimize cost and maximize reliability. The lessons from design, such as self-aligning components and consolidated castings, continue to ripple through the factory, enabling Tesla to assemble cars quickly without compromising precision. As modules arrive nearly complete, Final integration focuses on connecting these systems seamlessly, with alignment guides, pins, and standardized connectors ensuring that the battery pack, drive unit interior, and structural assemblies fit perfectly without constant human intervention. By reducing reliance on manual adjustment, the production process not only saves time, but also limits errors, meaning fewer reworks and defects down the line. Inline quality checks remain a cornerstone of this approach. Sensors constantly monitor torque values, panel gaps, seals, and electrical connections, while cameras and automated testing fixtures verify that each module meets specifications before moving to the next stage. Any deviation is corrected immediately on the spot, preventing small mistakes from escalating into larger issues. Statistical tracking of these measurements allows engineers to detect subtle trends over time, adjusting tools or retraining staff before any process drifts outside tolerance. This predictive oversight reduces scrap, limits warranty claims, and ensures that each Model 2 leaving the line maintains consistent quality. Meanwhile, the factory itself operates like a carefully synchronized machine, balancing automation with human skill. Robots perform heavy lifting, precise bolting, welding, and repetitive tasks that would slow manual workers, while human operators focus on intricate or delicate assembly operations that require judgment and care. Material flows are designed to follow near-linear paths from subassembly to final integration, eliminating the wasted motion, weighting, and handling that plague traditional factories. Each car receives a dedicated kit of parts at the right station, further minimizing search and retrieval time, and keeping labor focused on value-added tasks. Multi-shift operation, predictive maintenance, and real-time equipment monitoring ensure the production lines run for long stretches at peak efficiency, keeping machines operating at their design speed and reducing downtime. By maximizing overall equipment effectiveness, Tesla spreads fixed costs over more vehicles, sharply lowering per-car depreciation and helping make the $10,000 price target achievable without sacrificing quality. As 2026 approaches, the Model 2 is poised to redefine what a mass-market electric vehicle can be. By combining smart engineering, modular design, efficient material flow, inline quality assurance, and meticulous factory operations, Tesla shows that a $10,000 EV is not just aspirational, but attainable, proving that innovation in design and production can create real-world affordability without sacrificing performance, reliability, or quality that Tesla is known for.